for number 5, the answer is going to be B. So let's take a look at the breakdown. So we're told u is 1 plus root x. I'm going to write that as x to the 1/2. Du dx is 1/2 x to the negative 1/2. This we can rewrite in a much nicer way. So du over dx is 1 over 2 root x. And I want that to make dx a little bit nicer. So 2 root x du equals dx. So when we go to substitute in, I'm going to have the integral 1 plus root x to the 3/2 now becomes u to the 3/2 over root x times 2 root x du. And we simplify. So I have 2u to the 3/2 du. And B is our answer. All they did was they moved the 2 out in front, which is totally fine. On this next problem, u is going to be secant theta. The final answer for this problem, number 6, is B. So if we take u as secant theta, du dx, derivative of secant is secant tangent. So now du over secant tangent is dx, and we start to make our substitutions. So I'm going to have tan theta over root u times du over secant tan. The tan simplifies, but we have a leftover secant, and we saw this on an earlier problem. The leftover secant, we know over here that secant is equal to u, so we make another substitution. So now I have 1 over root u times du over u, which is going to give us the 1 over u root u that we see in the answer. The last thing that we have to do is rewrite the 0 in the pi over 4. When theta is 0, secant 0, secant is 1 over cosine, so it's 1 over 1, so I get 1. Secant a pi over 4, so it's going to be cosine of pi over 4 is root 2 over 2. We flip that upside down as 2 over root 2, which is just root 2. On this problem, number 7, our answer is going to be C. So if u is ln x, du dx is 1 over x, so x du is dx. So 1 minus ln x squared is now 1 minus u squared over x times x du. The x's simplify nicely, so I have 1 minus u squared du. We don't want to forget to switch the e and the e squared. Ln e is 1. Ln e squared is 2.